Good morning, dear students and viewers. Welcome to the second lecture on wireless communication and networks. Now, in my previous uploaded video, I had given a brief idea about frequency reuse and its importance in cellular communication. Apart from that, I have also discussed regarding the cell shapes, most acceptable cell shape, and why the cell shape is considered to be a hexagon. And apart from that, I have also discussed how to calculate the distance between two cells which are using the same frequency or channel, also known as the co-channels. In this particular lecture, I will cover how to increase the capacity of any particular cellular network. In order to increase the capacity, in last lecture also I mentioned that the best way to do is to reduce the cell size. That is, whenever we reduce the cell size, what happens? We increase the capacity of a particular cellular network. In that case, one thing I have mentioned there as well, that there is a limitation to how much we can extend the capacity without having interference a significant role in the cellular communication that we are interested in designing. Therefore, let us consider some of the other, or rather there are two other methods by which we can increase the capacity of a cellular network. The first method is known as cell sectoring. In cell sectoring, basically, if we consider a hexagonal cell, as I am drawing along with this presentation, so a particular hexagonal cell which earlier used to have only one particular allotted set of channel for communication and one antenna system, that is one base station, what we are doing, we are now using directional antennas to create wedge shaped cell sectors like this. So each cell is divided into number of sectors, and maximum possible number of sectors is 6, and the values of the number of sectors ranges from 3 to 6. So in this case, if we consider that how the communication is going to occur, we basically use directional antennas, that is a set of antennas which are going to produce a range of coverage in a particular direction, like this, like this, like this. So if we are using a set of antennas, their coverage will be like this. So all the 6 sectors are used, but with one particular condition, that all these particular sectors in a particular cell will have different frequency channels. That means earlier, if there were 6 frequency channels utilized by one particular cell, now there will be 2 frequency channels utilized by each sector of a cell. So this is how we basically improve the capacity of the cellular network. Now this is very much useful when we consider the cases of cities or metropolitan areas where the population density is very high, or we can say in those cases where the number of subscribers keep on varying from too high to too low. Now another way is, of course, by reducing the cell size from cell to microcell. So basically in this case, what we are doing, we are reducing the power associated with each base station or BS. So in order to do so, what we are basically doing, we are reducing the size of the antenna and we are reducing the power. When we reduce this both, the cell area decreases drastically. So decrease in cell area, as I mentioned in the previous case also, decrease in cell area increases the capacity but gives a high degree or high chances of interference. So this, everywhere this term interference is coming, so you must understand that this You must understand that this particular system is very much prone to interference, and this interference is going to play a very vital role in our next part of the presentation. So this is the basic idea, and one more thing to add, we can see microcells in our daily life as well in big buildings. Whatever big buildings you observe in the metropolitan areas, government buildings particularly, or private offices also, multi-storied, there you will find an antenna on the top. So that particular antenna is basically creating a microcell which is going to cover the subscribers or users within the building. So it has a very limited range of coverage. Okay. So the next slide. Now in this particular slide we will discuss the operation of a basic cellular system. What are the components associated with it? The components associated with it are basically the base station, which is having an antenna, controller, a transceiver. Okay, the main function of the controller is to handle the number of mobile units, and this number may vary with time. At the same time, the base station connected to mobile telecommunication switching office, MTSO or MSC, has the task to govern or operate or monitor, whatever you want to say, more than one BSC. That is, in one geographical location you can have one BSC, in another geographical location another BSC, another geographical location another, and all these BSCs are connected to the mobile switching center, MSC, and sometimes it is also known as MTSO or mobile telecommunication switching office. Okay, and the connection between the base station and the consecutive or the corresponding MSC or MTSO can be wired, it can be wireless, or it can be even optical link. So MTSO or MSC, I should write over here, or MSC basically handles the following task: connects call between mobile units and from mobile to the fixed line, that is even from landline to a mobile unit using what is known as PSTN or public switched telephone network. At the same time, it assigns the voice channels. That means, as I told you, that each cell is having a set of frequencies known as channels. So which channel is going to be allotted is decided by MSC. Also it performs handoff. Okay, in this particular presentation I am not going to the details of handout, because this is a very lengthy and this is a very in-depth topic which I will be covering in a different presentation of mine. And of course everything is restricted to the commercial domain as well, so it also monitors the billing process, that is what should be the charges associated with a particular call. And above all, there is no human factor associated or no human efforts, human labor associated with any of this particular task, as the entire system is fully automated. Okay, so this is the diagrammatical representation of what I tried to explain previously as a component of a cellular system. So as an overview, you can see this base station corresponds to, say for example, one geographical location, the second base station to another location, third is corresponding to another, and you can have so on. The number of BSCs can be more also. It depends upon the geographical location. So each mobile handset present in this location will be communicating directly to this BSC or BS, and each of these BS is connected to a MSC, also known as the mobile telecommunication switching office, MSC or MTSO, the one and the same thing. Okay, and ultimately, since the calls have to be made or should be allowed to be made from landline to mobile and vice versa, so there is always a requirement of the PSTN. So basically you should have PSTN connected to your entire system. So this is the overview of the cellular system. Now let us see how geographically we can explain this particular connection system. Now if this is a geographical area which I have marked by red, and this is divided into number of cells, each cell is having one base station, and each base station is connected to an MSC, which is in turn connected to the public switched telephone network or PSTN. So basically this is the diagrammatical representation how the cell phone telephone network work or cellular telephone network work. Okay, now each cell, as I told, is again and again I am repeating, each cell is having a set of channels, allowed channels, and these channels are again divided into two broad categories: the control channel and the traffic channel. Now control channel is basically responsible for setting and maintaining calls, and it establishes the relation between the mobile unit and the nearest BSC or PS base station. This relation maintenance and setting up calls is the main task of control channel. Please remember, there is no voice or data transfer using these channels. So there is no voice and data transfer using these channels. So what it is limited to? It is limited to transferring of only the relation signals or setting up signals. Okay, and then comes the traffic channels which carry voice and data. These are different from the control channels, and of course this will be carrying all sort of communication, whether it is data communication, whether it is voice communication, or simultaneously both. Okay, now these channels randomly are divided into 5 types of categories. Okay, first one is known as forward voice channel or FVC. This is used, please remember the direction is important. This is used for voice communication from base station, that is from base station to mobile. This is the direction. Okay, reverse voice channels are used to communicate from the mobile system or the mobile handset to the base station. Okay, so base station to mobile station or mobile unit. Okay, this link is known as the forward voice channel. Okay, and the communication link between the mobile system or the mobile phone and the BS or the base station is basically done using reverse voice channel. This is forward voice channel, reverse voice channel. Similarly, control signals also maintain the same type of channel direction or signal direction. Basically, the direction is forward control channel for base station to the mobile unit or mobile station, and reverse for the mobile station to base station. And please remember that forward control and reverse control are also known as the setup channels, and as I mentioned previously, these channels are control channels. They do not transfer or transmit any type of voice or data between the mobile unit, base station or MSC. Okay, going to the next one. Now if we want to analyze the anatomy of a cellular call or a originating cellular call, what are the processes or what are the steps that take place? These are the steps. At first we consider our phone to be switched off. Okay, the moment we switch it on or turn on our phone, though we are not engaged or we are not making any calls, the particular handset scans through a group of forward control channel. Remember, the forward channel is from base station to mobile unit. Okay, the group of forward control channels to determine which one is the strongest signal. Okay, that means one mobile phone can be receiving stray signals from many of the cells, but one of them will be the strongest, and maximum possible cases the strongest signal comes from the cells base station at which the mobile phone is located. So this is basically the first step towards establishing a call. The second one is it monitors that channel until it drops. A particular channel, okay, which is having the strongest signal is monitored until and unless its value drops down below a certain usable threshold. The moment it happens, it again starts scanning for the next channel which is having the strongest signal strength. Now this is also practically observed, this particular case, that if you are traveling very close to the vicinity of an adjacent cell, or you are not even traveling, you are simply staying, so there is the cell information display system of a mobile phone changes its location from one cell to another cell even if the cell is not moving. So this is happening because there is a continuous scanning or monitoring of the channels, and accordingly this monitoring finds out which channel is having the maximum strength, and correspondingly it connects to that. Control channels are defined and standardized over the entire area of service. That means you cannot keep on changing randomly and arbitrarily the value of the control channels and the voice channels. They are standardized, and since they do not carry any voice, they are also known as the overhead channels. That means they consume the bandwidth but do not transmit information. So the number of such control channel is limited to maximum 5% of the total. So if there are 100 channels allocated, so over a particular cell, in that case 5 channels will be reserved for only 5 channels will be reserved for the control system or the control channels. Okay, next slide. So now what happens, or what are the steps when we try to connect a mobile phone, okay, using from a standard landline? Okay, that is, we are using landline. Okay, we are using a landline phone to establish a call with a mobile phone or mobile subscriber. In case of mobile subscriber, we are not aware in which location the mobile subscriber is. So we are simply putting on the handset receiver and we are dialing a number. Okay, what happens? As soon as the same is done, since MSC is connected to PSTN, okay, the MSC dispatches the request to all base stations. Okay, what type of request it is? The mobile identification number is transferred as a paging message over the forward control channel throughout the service area. What does this mean? It means that whatever is the capacity or coverage of a particular MSC connected to a PSN, through that particular MSC or MTSO, all the base stations will be transmitted, since we are not aware that the phone is in which particular cell. So all the cells will be transmitted with one paging information containing the mobile identification number, also called MIN. And please keep in mind that this MIN is different from your called parties or calling parties phone number. Now, as soon as that mobile phone receives the paging message, the moment it receives the message, what happens? This message is coming from MSC to all the BSCs, but all the BSCs are not having that particular phone. Only one BSC is having. So when that particular mobile phone or mobile subscriber or mobile system receives the paging message, it responds over the reverse control channel. Okay, that is RCC. The base station conveys the handshake to the MSC. That means that particular BSC which is identified to have the mobile phone in its location, it sends or conveys a message to the MSC which is known as a handshake message, that the MSC instructs the BS or the base station to use voice channel or to move to a unused voice channel. That means MSC is the equipment, or MSC is the main guiding or main monitoring unit which sends the information to the BS, corresponding BS, not all. Once the handshake is completed, that means the mobile phone is identified to be in a particular BS. That particular BS is instructed by MSC to move to a voice channel which is unused till now. So unused forward voice channel. This particular instruction is provided by the MSC. Now, as soon as the call reaches to the calling party, what happens? Now, the base station signals the mobile subscriber to change over to the forward voice and reverse voice channel. So these two forward and reverse voice channels are fixed first of all. That your cell phone is going to converse or communicate with the base station through which forward and which reverse channel. Okay, which forward and reverse voice channels. So once this is established, a data message is transmitted over the forward voice channel to instruct the phone to ring. So basically this is the first time at which your phone is giving you a ringtone or a ring call, or you are instructed that you are having a call. Okay. All of the sequence of events occur in just a few seconds. So you might be thinking that so many tasks are taking place, so it is going to take a lot of time. No, it doesn't take a lot of time. It takes only few seconds, 3 to 4 seconds before the call is established and you get a ringtone. Okay. At the same time, what happens? Your mobile switching center. This is also very important. Please pay attention. This is also very important, as the mobile switching center adjusts the transmitted power. Okay, it adjusts the transmitted power in order to maintain the call quality. Now what happens? Sometimes you will see that all the subscribers are not equidistant from the base station. So within a cell also there is a difference of power, and this power difference can easily be seen in any of the smartphone settings. If you go to the settings, you will find there is a section which shows the signal strength. So this particular signal strength is also communicated, okay, to the MSC, so that it can transmit or regulate the power to maintain a particular call quality. In case the subscriber is close enough, that much high power may not be required. In case it is far enough, it is required to have a high power. But with the evolution of this entire mobile cellular communication system or cellular network, what has happened? MSC has become more and more overloaded. So there are cases when most of the power or most of the monitoring task MSC transfers to the BS and BS transfers to the handset itself. Nowadays, with the incorporation of microprocessors and different type of integrated electronics within the mobile phone itself, these type of controlling are handled on the subscriber side or on the base station side maximum without the involvement of MSC also. Okay, but still it is in the architecture of the GSM, okay, the protocols that are available from the GSM. So it is basically important to mention it. Okay. Now, what happens when we try to make a call from a mobile user to a mobile user? Okay, or from a mobile user to a landline. Earlier we have seen a case that the call is originating from PSTN or landline to mobile. Now we will consider the case the call is originating from the mobile itself. Now see what are the steps. A call initiation request is sent to the base station using reverse control channel. Remember, I told you previously also, the direction is very important. If you are taking the mobile station and BS, from mobile station to BS, it always takes reverse control channel. Okay, so as soon as this request is sent, along with this particular request, the mobile subscriber also transmits some data. What are these data? These are mobile equipment number, mobile identification number, electronic serial number, and phone number of the called party. That means these three numbers are also transmitted by the mobile subscriber to the base station. Along with that, the mobile subscriber also transmits station class mark, which is known as SCM, that indicates the maximum power transmitted using which is the maximum power to be transmitted from that particular user. Again, that depends upon the geographical location of that particular handset, location of the particular handset with respect to base station. So the base station forward the data to the MSC, and it is the task of this MSC to authenticate the legality of the call. When I mean investigate the authenticity and legality, it investigates MIN, mobile identity number, electronic serial number, and it sees whether you are at all in a position to make that call, whether your equipment is legal. Okay, in that case only your call is established through PSTN. So these are the steps which basically covers, and in this diagram I have tried to show what are the different types of communication, whether it is unidirectional and bidirectional or both. Now this is the case in which a mobile phone is just switched on and it tries to locate the highest or the strongest signal from a particular base station or base station antenna. In this case, most of the time it is, for if we consider this particular car which is having a mobile phone and it is switched it on, in that case the base station which is having that particular cell phone will definitely be closest and it will provide the strongest signal, so it establishes the connection with this particular base station. So request for connection, you can see request for connection is from the base station to the mobile switching center, MSC. Okay, so MSC, again I am repeating, MSC and MTSO are not different units. In some of the books and literatures or presentations, you will find it is written mobile telecommunication switching office, or somewhere it is written mobile switching center. Now this is important and interesting. What is paging? As soon as call request arrives to a particular MSC, it sends the page information to all the associated BSCs, but only one which is having that particular cell phone response back. And you can see the establishment of the connection is shown in this particular diagram, that is part D, that is call accepted. You will have a connection between MSC to BTS and BTS to the particular handset, and again from the handset to a BTS and BTS to a particular MSC. Okay, that means this person is the called subscriber and this is the calling party. Okay, so again this is an ongoing call. You can see the ongoing call, the called party is communicating to the BTS in a duplex channel through the MSC, and similarly there is a duplex connection from MSC to the called party or calling party, whatsoever you can say. These are interchangeable as both are bidirectional. So handoff basically is a process in which while moving a particular mobile subscriber crosses one of the BTS and enters another. In this particular case, what happens, as it moves to the boundary of a particular cell, the power it is receiving from the corresponding previous BTS antenna decreases, and gradually as it enters another cell, the power received from that particular base station's antenna increases. Thereby there is a process in which the allotted channels are handed over from one particular base station to another without interrupting the call. This is important, without any interruption. Without any interruption, the channels are transferred from one BS to another. So this process is known as handoff. So handoff in itself is a very vast topic. So I will be taking up handoff in another lecture. Thank you very much for your patient hearing. If you have any question, you can please communicate to me through the comment section, and as soon as the time permits, I shall respond. Thank you very much.